Far away from cities, far away from artificial lights, and far away from everything we call modern civilization, there exists another world. A world where vision is not comfort. A world where sight is not beauty, but a strict survival system that decides in an instant who remains alive and who disappears into silence. In this world, some creatures possess eyes so large compared to their bodies that they seem almost impossible by normal biological logic. Eyes that dominate their heads. Eyes that reshape skulls, nerves, and even behavior. Eyes that were never designed for aesthetics, but for one purpose only: survival under extreme conditions. Because in nature, vision is not measured by how beautiful the image is, but by how fast it can prevent death. To understand why some animals evolve enormous eyes, we must enter environments where sight is constantly under pressure, where light is rare, where darkness is dense, where movement happens in fractions of a second, and where missing a single visual cue can end everything. We begin in the deepest place on Earth, the deep ocean. A realm thousands of meters below the surface, where sunlight has long since disappeared. There is no sunrise here, no sunset, no horizon. Only a vast, crushing darkness that stretches endlessly in all directions. In this environment, vision is incredibly expensive biologically, because light itself is rare. And so evolution responds in a dramatic and unmistakable way. It enlarges the eyes. Not slightly, not gradually, but to extreme proportions. One of the most iconic examples is the giant squid, a creature that lives in one of the least accessible environments on the planet, rarely observed alive by humans. Its body is enormous, powerful, and adapted to pressure most animals could never survive. But its eyes are even more extreme. Each eye can reach the size of a human head. At first, this seems almost absurd. Why would an animal living in near total darkness need such massive eyes? The answer lies in what darkness truly means in the deep sea. It is not absolute nothingness. It is a place filled with micro signals of light, bioluminescent flashes from plankton, faint glows from drifting organisms, subtle silhouettes of movement against the minimal ambient light from above. The giant squid does not need sharp images. It does not need color detail. It does not need precision like surface animals. What it needs is sensitivity. Its enormous eyes function like ultra-advanced biological sensors, capable of detecting the smallest contrast between light and shadow. In the deep ocean, survival is not about recognition. It is about detection. Not what is it, but is something there? Because in this environment, hesitation is fatal. A predator like a sperm whale can appear with almost no warning, and prey can vanish in an instant. So evolution favors one thing above all else: maximum light collection. And that is what giant eyes provide. But the deep ocean is only one extreme world where vision evolves beyond normal limits. If we rise toward the surface, we enter another environment shaped by a different kind of darkness. The tropical rainforest at night. Here, darkness is not total. It is layered, broken, dense. Light struggles to pass through thick vegetation. Moonlight is fragmented before reaching the forest floor, and the ground becomes a shifting landscape of shadows and sound. In this environment, nocturnal hunters rely heavily on visual adaptation. One of the most striking examples is the tarsier, a tiny primate from Southeast Asia that looks almost alien in appearance. Its body is small and lightweight, but its eyes are enormous relative to its skull. so large that they cannot move within their sockets. Instead, the tarsier must rotate its entire head to shift its gaze. If humans had eyes proportional to a tarsier, each eye would be the size of a grapefruit. Why such extreme adaptation? Because tarsiers live in a world where light is scarce, but not absent. And in that fragile balance, every photon matters. Large eyes allow maximum light intake into the retina. This increases sensitivity in extremely low light conditions.
Which means that even the faintest movement becomes visible. A single insect shifting on a leaf, a small shadow crossing a branch, a subtle vibration in the darkness. All of it becomes readable. The tarsier does not rely on endurance. It does not rely on strength. It relies entirely on speed of perception. Because in its world, seeing first means striking first, and striking first means surviving. But evolution does not stop at mammals or deep-sea giants. It moves into another domain entirely, a world defined not by darkness, but by motion, the sky. And here we encounter one of the most visually advanced systems in nature, the dragonfly. A creature whose eyes are so large, they dominate its entire head. Its body almost feels secondary compared to its visual system. Each eye is composed of thousands of microscopic units called ommatidia. Each unit captures a slightly different angle of the environment. Together, they form a near-complete 360-degree field of vision. In the world of the dragonfly, nothing is truly hidden. A mosquito in flight, a flicker of movement near water, a sudden change in air currents. All of it is processed instantly. Not as a single image, but as a continuous flow of motion data. The dragonfly does not see in frames like a camera. It experiences reality as a constant stream of movement probabilities. This is why dragonflies are among the most efficient aerial predators on Earth. They do not chase randomly. They calculate interception paths in real time. They move not toward where prey is, but toward where prey will be. And that level of prediction is only possible because of their extraordinary visual system. If we look closely at all these creatures, the giant squid of the deep, the tarsier of the night forest, and the dragonfly of the open sky, one pattern becomes undeniable. Large eyes always emerge under one condition: when survival depends heavily on visual information under extreme environmental pressure. In the deep ocean, eyes grow large to capture nearly non-existent light. In dark forests, eyes grow large to extract every possible photon from shadows. In fast aerial environments, eyes grow large to process motion at extreme speed. Nothing is random. Nothing is excessive without purpose. Every millimeter of eye growth is an answer to a problem the environment demands. And the harsher the environment becomes, the more extreme the biological solution evolves. Back in the deep ocean, the giant squid drifts silently through a world that barely reveals itself, its massive eyes scanning for the faintest hint of life. In the rainforest night, the tarsier remains perfectly still for a moment, then locks onto movement and explodes into action. And in the open air, the dragonfly cuts through space with precision so fast it seems almost beyond perception. 3 worlds, 3 forms of life, 3 different strategies, but all driven by the same fundamental truth: vision is power. And in the natural world, those who see first survive longer. Because in the end, eyes are not just organs for observing the world. They are the thin boundary between existence and becoming invisible to time itself.